Okay, so this is 5-5, and we're solving polynomial equations. This is just going to kind of piggyback on what we already started with our notes. So first thing we're going to do, we're going to pick back up in example 2, and we're going to continue factoring by grouping. So the example we're going to do is we're going to factor the polynomial. Obviously, if it can't be factored, we're going to call it prime. Okay, so the equation we have x cubed plus 5x squared minus 2x minus 10. First thing we want to do is just rewrite our original equation. After we do that, we want to group these together and just make it easy on yourself and just group sides together to find a greatest common factor. After that, factor out the greatest common factor for both sections. So the greatest common factor with x cubed plus 5x squared is x squared. Leaving us with x plus 5. In negative 2x minus 10, greatest common factor is negative 2, which leaves us with x plus 5. If you'll notice, both sets of parentheses have the same thing in common, so we'll rewrite that as x plus 5, and then we'll account for the things outside of the parentheses and put them in another set of parentheses as well. That gives us x squared minus 2. It's kind of like the distributive property. If you look at it, if we were going in the opposite direction, if we were working our way back up, we would distribute the x squared to the x plus 5, and we would distribute the negative 2 to the x plus 5. But really, this is more of a reverse distributive property. We're kind of working backwards. So if I ever say reverse distributive property, that's what I mean. So our answer is x plus 5 times x squared minus 2. So we're going to do another example. This time we have a squared plus 3ay plus 2ay squared plus 6y cubed. So I jumped ahead on that one. But here's what we'll do. We'll work through it and rewrite our original expression. And then you can continue to work this one all the way out. When you work it all the way out, in the exact same order as the first time, our answer is a plus 3y times a plus 2y squared. Feel free to pause to see and check your steps on this and work your way through that. Next, for example 3, we're going to combine cubes and squares. So it's going to look a little different, but we're still going to go through the same steps, remembering always to refer back to all of the rules in the tables that you've created. So we're going to factor the polynomial. Again, if it cannot be factored, we're going to write it prime. I'm not even going to attempt to say this whole thing. This is the equation that we're given, or excuse me, the expression that we're given. And so the first thing that we probably should do is group to find a greatest common factor. So split it apart down the middle. We technically have 6 terms, so let's factor by grouping first. So split it apart and let's get ready to factor. So once we've split this equation, we can now go into factor, and the front half only has y to the third in common. The back half only has z to the third in common. If you'll see, our parentheses are the same values, so we know we're working in the right direction. Now, after we factored out the greatest common factor, we're going to go back to that distributive property, or that reverse distributive property like I stated earlier, which we basically just rewrite what's in the parentheses and what's outside the parentheses. Now that we've got this equation or this expression set up this way after factoring greatest common factors, we can now move on to, and this is just the same equation rewritten that we just had from our last page, we can now go through and apply the sum of cubes rule. Now if you're getting confused as to how this answer just popped up, here's how we're going to come up with that. We have y to the third plus z to the third. So we're going to take our right side of our equation, the x squared minus 3x plus 2, we're going to let that hang out for a little bit, and we're going to use y to the third plus z to the third, and we're going to plug that into our sum of cubes rule. So when we do that, we understand that we have to rewrite our parentheses the way we have it, and then once we plug in our a and b values into our sum of cubes rule, that's how we go from the circled y to the third plus z to the third breaks apart into a sum of cubes expression where we have y plus z times y squared minus y times z plus z squared. Then we just take our second half in the green up there, the x squared minus 3x plus 2, and just bring it down behind that part of the equation. So now, going back to the answer we just had, bringing down that second part of the equation, there's actually more we can do here. So what we can do additionally is this. Let's take our original sum of cubes equation that we've got, and now looking at the second half of that equation, we have x squared minus 3x plus 2. This is just going back to just regular, easy quadratic factoring. So x squared minus 3x plus 2, what we're looking for is values that we can multiply to give us positive 2, that we can combine to give us negative 3. When we do that, we see that we're left with x minus 2 times x plus 1. At this point, our entire expression has been factored down as far as we can factor it. So I rewrote my answer and just rewrote it in an order where I had my x minus 2 and x minus 1 at the beginning of my equation. The green and the blue at the bottom, they're the same answer. Both of those will be considered correct. I just like writing my sum of cubes expression at the end. Moving on, let's do one practice example really quick. This one's going to look a little different because we've got a couple of steps we're going to begin to integrate here. So we've got 64x to the 6th minus y to the 6th. So I'm going to rewrite my original expression. Again, it's not an equation because it's not set equal to anything. It's an expression. And what we realize is this, is we've got perfect cubes. And what I mean by perfect cubes is we can rewrite this expression in a different way. It's actually by applying the difference of two squares rule. And here's how we're going to go about doing this. When we apply the difference of two squares rule, we can rewrite the expression as 8x cubed plus y cubed. And I know right now the way it's written, it says 8x cubed plus y cubed again. The addition sign in the second part should be subtraction, and I'll change it later as I go through explaining this equation. But for the time being, this is how we can separate and break this apart. If we were to, I hate saying it, FOIL this, it would take us back to the 64x to the 6th minus y to the 6th. So next thing we're going to do is I'm going to fix this sign really quick. Now, what I've done here is I have applied my difference of two squares rule. And so I have a sum and a difference of two cubes. So for my 8x cubed plus y cubed, I applied my sum of two cubes rule. That's the left side of this green equation. And then on the right side, I have 8x cubed minus y cubed in the blue. That's the difference of two cubes. That's just the second part of my green equation. Okay? That's my answer, all in the green.